All right, today we're going to walk through some I/O testing scripts and uh, some things to make that easier for you if you have to do that kind of work. So I've got a Jumpbox server here, an I/O test user. In the folder, I've got an output and scripts directory, and that actually corresponds to a folder in my HTML directory, so everything's published there, immediately. So in the we'll look at the output folder first. We've got a few directories here. I've got a CSV file that I'm writing out to all the results, and I've got an archive logs, results, and temp directory there as well for some processing. In the results log, you'll see some folders that are created based on date. Same with the log directory, and I'll show you how those work later. But in the scripts directory, I've just got this quick, well, it wasn't that quick actually, but this bash file, bash script called multiboot.sh. If we take a look at that, actually what I'm going to do is we can see right now that these directories are empty, and they've got those folders in them, but there's no results in them. But what I'm going to do is I'm just going to kick a job off here, and then I'll go through the file and show you how it works. Let that run. So looking at the file, essentially I've got some variables set up here, and I'm creating these instances in a on OpenStack. So you'll see image name and network ID and an availability zone. If you want to push the load all to one hypervisor to test one hypervisor, you can narrow it down like that. Your count is how many instances you want to spin up for this test. Machine name is just the preface of when the machines are created, what those are. It's going to be IO test dash and then the machine name number. User data is what I'm running in CloudNet to actually run the IO test. I've got some output directories and result and log directories set here, and I create a today variable so I can write output per day into different areas. I do a quick check to see if these directories and result file exists. That CSV, the first time this runs, if the CSV doesn't exist, it creates that CSV and it puts a header on row 0 on that to make it easier reading. So in the user data, so when each instance boots, the last thing CloudNet does is execute whatever I pass to it in the form of user data. So set a home directory. I'm using an SSH key to upload this directory. You could use FTP, but I was running into all these things where the put FTP behind NAT and passive mode and all that stuff. So I have an SSH private key in here. Probably not best practice, but I wanted to get this done quickly, so I stopped messing around with FTP. FIO is the tool that I'm going to use for the actual benchmarking. I set some outputs. I have to set some outputs here. I didn't have to, but I set them here today because I'm uploading into folders and I didn't want to write it all out at the bottom. So I set those paths here in my variables. I've got a text. FIO spits out. I'm spitting out a text and a JSON file, just for convenience, really. So the first thing you do is install FIO, and I also installed a Java query binary, and you'll see why I do that later. The generate test files, I actually not going to use this. I was generating some dev urandom files for input and output, but FIO does this for me automatically, so I can just take that out of there. Actually, these echoes are just when I grab the CloudNet log and I'm trying to debug something that's working or not working. I'm echoing some things out here so I can make sure stuff's working there. I create an FIO config file. This is a very basic FIO config file. I'll come back as I do different block sizes and different I/O schedulers and things, and I can make those changes here. So I'm again echoing out to the log. Here's actually where FIO is running. It defaults output to text, and then I put a JSON format. And when I since it's in JSON, and in this video I won't go over the actual file, but I'm querying the JSON values out and grabbing things out of that output that I need, like the read IOPS, and the latency comes in microseconds, so I convert that to milliseconds, and I report back both into the file. But when these are done and these variables are captured, it writes that out to a local CSV. It echoes some stuff about the time being completed. I do some math on the time. I capture epoch time and the date, so I'm just reporting out how long a job is running and things like that. There's my SSH key. You can disregard that. So after everything's done, it schmods the key, then it does an SCP and ignores strict hostname checking, so you don't get that pop-up that says accept the host key, yes or no. So it gets rid of that. Uploads the text file to my jump box into that result directory, which is set above based on today's date. It sends up the JSON file, sends up the cloud init log. In case there's any errors, you can disable that if you know everything's running fine. And then it uploads the CSV, and it does this. It boots this n number of times, how many ever you put your count for. So this is all just creating the user data file, and the actual work of creating the instances, it sources a credentials file, and then I just loop through the instance count, right? So I start with count of 1 up to how many ever, 4, 8, 16, 32, how many ever you want, and then it just does a nova boot command, references my key, the flavor I'm using, the image, the network ID I want these to land on, availability zone, and then my user data file, and then it gives it a name of that machine name variable, dash count. So it's going to be -1, -2, -3, -4, etc. I put a sleep in here. You probably don't need it if you're doing under 10 or 20 instances, but when you start doing hundreds of instances, you probably want to put a delay in there so you don't overrun the control plane. It does one more sleep, and then it just spits out the Nova list to show everything's running. So in the cleanup, this is really kind of the cleanup and reporting section. I remove the user data file, so I don't have any old data there, especially the key and stuff like that. So and then I echo this many tasks running. On the first pass, I set the complete count to 0. I kept running into this thing where I was doing an ls on star.json in that directory, and I couldn't get that into a numeric variable, so I just set it to 0 there. And then it goes through and it's doing complete count of total count, and while those two numbers don't equal, good God, while those two numbers don't equal, it's going to wait till they do equal, and it's going to sleep 30 seconds. And if that directory has output in it, it's going to set the complete count to how many ever CSVs I have in that directory. Otherwise, it's going to continue to set it to 0. It's going to continue to loop through that, and then when complete count equals total count, then that kind of wait is done. So then I can come down here and start the cleanup. Echo everything complete. I loop through again, and I just go through and delete these instances with instead of nova boot, I'm doing nova delete. I then take everything. Well, I concatenate. I grab the new CSVs that were dropped in there, and I push them up to the result file, and then I basically archive everything else. And the reason I did this, I didn't want to put subfolders in each day based on the run name or something like that. So I'm just wiping everything out each time, and I'm just grabbing really the data. I'm archiving the data I don't, care so much about, and then I'm just concatenating that CSV up to the main file. So we'll see what this looks like from an output standpoint. So we just caught it in time. So you can see here it finished. It finished. It finished running the or booting the instances up there, and then it's gonna, after it's done booting, it just sits here and waits until all of the CSVs are brought up. Oh, it looks like I still have one more error in here, but anyway, it it sees that all the instances are complete. It deletes them, and then it just cats out that complete output file. So what you see, here, back to our output directory, the results, directory is still empty. That's already been moved over to the archive file, and these are multiple runs that are kind of adding up in there. And then really the thing that we're primarily concerned with is the results, is this CSV, is where I'm rolling everything up to. So within that CSV, you now see host name, read IOPS, latency in microseconds and milliseconds, write IOPS, and latency in microseconds and milliseconds. So this is just the base framework. As I do more testing, I'll change block sizes and IO schedulers, and I'm going to be testing against multiple disk speeds and RAID types and stuff like that. So I'll add those columns later for it to tell me how many disks I'm writing against, or disk count, disk speed, RAID type, CEF, NFS, etc. So that's it in a nutshell.